Hi, this is Karthik. Me and my team are gonna have a short talk on bus and bus structures. To start with, to know what is a bus. Uh, a bus is a communication pathway connecting two or more devices. An important characteristic of a bus is that it is a shared transmission medium. So, multiple devices can connect to the bus, and signal transmitted by one of them is available for reception by all the other devices attached to the bus. But if two devices transmit during the same time, their signals will overlap and become garbled, so it won't work. So only one device can successfully transmit at a time. Now let's briefly see what is the bus structure about. A system bus consists of 50 to hundreds of separate lines. Each line is assigned a particular function. Although there are different bus designs, the bus lines can be majorly classified into three functional groups: data, address, and control lines. The data lines provide a path for moving data among the system modules. These data lines collectively are called the data bus. The data bus may consist of 32, 64, 120 or even more separate lines. The number of lines together are referred to as the width of the bus. Since each line can carry only one bit at a time, the number of lines determine how many bits can be transferred at a time. Since the more number of bits that can be transferred can be very essential, the width of the bus becomes the key to it. Next, the address line. The address line is used to designate the source or destination of the data on the data bus. The width of the address bus determines the maximum possible memory capacity of the system. When a computer component wants to communicate with another, it uses few of the specific bus lines to specify the destination component by using its address. These lines are commonly referred to as the address bus. And the last, the control lines. The control lines are used to control the access to and the use of the data and address lines. Since the data and address lines are shared by all the components, there must be a means of controlling their use. Control signals transfer both command and timing information among the system modules. Timing signals indicate the validity of the data and address information. Command signals specify operations to be performed. There are several control lines, but typical control lines include. Now let us see some of the control lines. Memory write. It causes the data on the bus to be written on the addressed location. Memory read. Causes data from the address location to be placed on the bus. I/O write. Causes data on the bus to be output to the addressed I/O port. I/O read. Causes data from the addressed I/O port to be placed on the bus. Interrupt request. Indicates that an interrupt is pending. Interrupt acknowledgement. Acknowledges the pending interrupt has been recognized. Clock. It is used to synchronize the operations. And at last, reset. It initializes all the modules.